class, this is Mr. Fudge, and you are making coffee with Mr. Fudge today. And so I like to, well, I never really start out coffee with pieces of ice, but hey, this is just so you can see the solid state of water. You're all familiar with it. It's just water that has been frozen and gone solid. And so whenever ice or something becomes, that is a liquid, becomes a solid, it's because the heat has been taken away from it. That means the heat has been transferred out of it. And so just so you can see what's happening with the different states of matter, we can take a look at it. And so we have, whenever we have a solid, the molecules are the tiny little parts, such as in water, you have H2O, 2 hydrogen, and 1 oxygen. That molecule that's built off of those 2 elements has different pieces, and those pieces come together to form the liquid. And the liquid would be further apart. Now, if those molecules were really close together, as in ice, you'd have a solid. And that's whenever all the particles are super packed tight, close together. And so whenever you remove the heat, whenever you take the heat out, the particles come together. Whenever you add the heat in, the particles get further and further apart. And so that's whenever you have those changes of state occurs whenever heat is applied. That's the typical occurrence. And so you start with a solid and it becomes a liquid whenever heat is added, and then as more heat is added, the particles spread out even more and you have a gas. Now if you take the heat away, the particles get closer and become a liquid, and then they become a solid again. Any solid can actually be turned into a liquid and then also into a gas. Liquids are actually quite rare if you think about it. There's not many liquids you can think of that don't already contain water. That's why water is such a unique substance. With water, the melting point is 32 degrees Fahrenheit or 0 degrees Celsius. And the boiling point is 212 degrees Fahrenheit and 100 degrees Celsius. Well, something interesting is also that the melting point and the freezing point are actually the same. That means something's got to give at that temperature. That means whenever there's enough heat added, there's a rapid expansion of melting occurring. Whenever there's enough heat being taken out, there's a rapid expansion of freezing occurring. So again, the solid, liquid, and gas states are because there's energy being applied, such in this case as heat. And now if we look back at our water, or our ice, it has now become liquid because we added heat to it. I'm trying not to damage my equipment here. There we go. Cool. Now the boiling point, you'll see it here in just a second more rapidly. The boiling point is the point of vaporization of a liquid. That means the water, in this case, becomes so energized. It means there's so much heat coming from the electrical unit to the coils, the heat coils, to the metal, to the water, that it begins to explosively boil. And you can see that here. Now this is called a rolling boil. And so now we have this water vapor. And the water vapor happens because the vapor pressure, that means those tiny molecules that are getting energy added to them, the heat is going into them, they start to move rapidly and move apart. And so then they become vapor. Well, the vapor pressure becomes so strong that it overcomes the atmospheric pressure. That means the air pushing down on this, and there is air pushing down on it, is creating a force. And then the vapor is also creating force because it wants to release, it wants to get out and move. And so the water vapor is pushing up, atmosphere is pushing down. The point at which the vapor pressure becomes so strong that it overcomes the atmospheric pressure is when you get water vapor. And so another science thing to remember is, I don't want to touch this. This is not something you do at home without a parent's supervision. Again, do not do this at home without parent supervision. And so we have boiling water, was once a solid such as ice, is now a liquid, and now you can see we have a lot of gas being formed, water vapor. And so I have a glove on. I can touch this pan that is super hot because I have a glove on. The heat cannot transfer into my hand out. See, the heat did transfer into my hand from the actual water vapor. Again, this is steam or water vapor, and it's hot. And I just burned myself a little bit. Ouch. And so now it's not hurting me at all because I am holding it with an insulator. An insulator stops the flow of energy, of heat energy. Maybe not stop it, more so it slows it down. And so if you notice, this metal is a conductor of heat. There's metal coils down inside the stove that the electricity moves into. It moves into it so rapidly so that it creates friction, which creates heat, and that heat travels through that conductor, which is the metal coil, then through the glass stove, into the metal pan, and then into the water. And so that metal pan is the conductor. Think of a train. The train driver is the conductor. He drives the energy forward. And so the metal drives the energy forward. And this slows it down, if not stops it, depending on what you're using. So now we have boiling water. That's not enough to make coffee. So I know, movie magic. I'm going to remove this real quick. We're going to take a look over here, turn off the burner for a moment. And what we have here is what's called a French press. Okay. Ooh, almost burnt my camera. We have a French press. And this is something you put the coffee, you take coffee grounds, you scoop out coffee grounds, the powder coffee, and you put it into this. It looks like a beaker with a handle. And you put the coffee grounds at the bottom. And then you pour the hot water on top, which I've pre-prepared. And so you can see there's coffee grounds on this. And so this pushes down, and I'll show you that. This coffee should be ready. You're probably tired of seeing it move. Here we go. So I'm going to push down on this plunger. And the plunger pushes down the coffee grounds. Now, I'll say this, the coffee grounds and the water was a mixture originally. That means there was big particles, and you could see that too, big coffee ground particles mixed into the water. It's a mixture. I could take those coffee grounds out if I filtered them, and that's what that thing did. It pushed down the coffee grounds and separated them. But there's also really tiny, tiny coffee ground particles that fit into the water or dissolved into the water. And so in this case, the water is the solute. I'm sorry. The water is the solvent. The substance that catches the particles. It's the solvent. And then the pieces or the things that you put into it, such as sugar, salt, coffee grounds, the tiny particles that go into it and dissolve, if you remember from your explore activity, are called the solutes. The solutes, the tiny particles. Now think of the water as a parking lot. The water has so many spaces that the little cars can park in. Okay, and so there's those water particles. In between those particles are those parking spaces. And so when you put salt in it, or we'll just use the coffee ground particles. Whenever you put the water and the coffee grounds together, tiny little particles of the coffee park in those spaces in between the water molecules. And it holds them together. They start to bond together. A lot of times they're hydrogen bonds because water is made out of hydrogen and oxygen. And so you have weak hydrogen bonds that are grabbing hold of these other types of elements or chemicals and holding on to them, and so that's why they dissolve. The reason the sand didn't dissolve in the water during your explorer is because the grains were too big, just too big, and they didn't bond with the water. And so whenever we put the coffee in there with the water, those particles bonded with it, or they parked in the parking spaces of the parking lot. They dissolved into it. Coffee, just so you know, is measured in TDSs, total dissolved solids. You can also think of that as tiny particles. And so that's making coffee with Mr. Fudge. I'll say this too, again, don't forget your insulators and your conductors in this, okay? Solvents, solutes. Again, just a recap, we looked at solids turning to liquids and then turning into gases, which you can still see here again as well. Then creating a mixture, and then also a solution. And of course, we don't want it to burn, so we use insulators to stop the flow of heat energy or even electrical energy, depending on what you're dealing with. Thank you so much.